Well, curiosity had gotten the best of me a little while ago, and then again, and I'm kind of glad that most recent curiosity worked out because it may help some questions that were asked early on with this stuff. At any rate, this is one of the Lights of America LEDs that I'd shown 2 watt. I think they said 150 lumens. So I'd taken this apart to see, again, having the real nice LED driver circuit in Utilitech. Was curious what some of the other bulbs did. These basically have a bridge rectifier, and then a little puck of 3 LEDs is essentially wired in series with the next one and wired in series with the next one, and each one has a filter cap, and then a electrolytic across the start finish point then, and then there's a current limiting resistor inside. So it's a very simple, you know, rectified and filtered circuit, but does kind of explain to some extent why they're sensitive to where they run at. And the more recent curiosity was to take apart one of these foreign bulbs. They do claim to be dimmable, I think from 180 to 220 volts. And with running them, it seemed like there was something in them, at least that made them more able to vary voltage as compared to the Lights of America. I noted it might possibly have an actual driver in there, like the Utilitechs, because of the response with the cap on the secondary. However, I did take these apart, and I believe we can answer some questions that were asked early on. These bulbs on the inside, you can just actually unscrew them here and here, and then the 3 layers will pull off. They are wired in series, so you have 12, 12, and 12, 36 bulbs total in series. And the circuit I've got sitting out there, the bulk of the circuit, and then the parts that I've taken off. Sorry about that. And sorry again. And the reason for doing, I basically went step by step and isolated stuff, and this is as simple as we can get. And the question that was asked early on was, can we take a string of LEDs and essentially go through a super Joule ringer type design and then rectify it and filter it and gain some sort of advantage? Well, more or less the Lights of America circuit is doing almost that, and then these foreign bulbs are as close as you can get to that exact thing, with minimal number of parts, minimal circuit design, and so I'll explain more if somebody wants to start playing around with super Joule ringers and doing their own strings of LEDs. I believe it's possible, and variables are fairly small. So initially we'll show off just running one bulb. Got everything kind of in the way there, but yeah, one bulb in the middle, wires running all the way up, so it's DC, being sent down from there. All of these bulbs are more or less DC. The Lights of America's DC output to the LEDs, the foreign bulbs DC output to the LEDs, the Utilitech's DC output to the LEDs, and they're all pretty much filtered. So yeah, I've got a wire length going into the box, but there's one bulb in there set in the same point that we run it on AC, and AC, I've mentioned in other videos, was 290 lux. It's set on 1x. So yeah, the bulb's been changed, the circuit's been changed, and we'll just run it here. Nothing, that's not the point of this. The point of this is the fact that we can run strings and rectify it on the end. So we'll just run this up and see what we get. Okay, 11.9 volts, 140 milliamps. That's around 1.6 watts, 580 lux. So that's exactly twice what the output would be on AC. But I guess here this is the lowest wattage thing that I've shown. 1.6 watts is getting pretty down there. Uh, Again, lumens are still unknown. I would say we're well into the 100 lumen range. Using my various calculations, but until we can get it confirmed or something. But it is double what it was doing on the 110. Granted, it's a 220 bulb, and we're only spending 1.6 watts. And a note, with this transformer, it won't run base untied. So you do have to keep it tied. Resistance to the base is at 250 kilo ohms right now. You can run it down 5 kilo ohms, you'll be drawing around 1.6 milliamps and around 650 lux. So I was just trying to figure out the lowest point that I could get as far as wattage and still have some decent light. So I'll shut that off. Alright. So the circuit that's inside these, I had it drawn out here a little bit. Okay, so this is the starting circuit for 220. If this would be the socket, the side of the socket that goes in here, and the end, the tip, the hot feed goes in here. It basically has an RC filter there on the input and 4 diodes to make a full wave rectifier. The output then has an RC electrolytic resistor, and then the diodes are just connected up to that. And then if you look at its rated 220 volts, divided by 2, we're at 110 after we full wave rectify it. Then is cap filtered, divided by 36 bulbs in series, we end up at 3 volts per bulb. So these are actually then directly lighting off their operational conduction range, from whatever that would be, 2.5, to 3.3, 3.5 volts, somewhere in there. So this can be done with virtually anything. Now I've changed these. I'm no longer running the 36 in series. I'm running 12 and then 3 in parallel. It was to see if even modifying that and running the same transformer, if I would get any dramatic change in efficiencies, or in fact be the same, which would kind of prove that we can do this. So I'm running essentially what would be a 72 volt rated, and then 36 volts across the LEDs. And again, I took off piece by piece and worked it down, and here's the minimum you need. An input cap in series off our proverbial hotline, and then just a full wave rectifier, and then standard electrolytic cap filtering on the output. It does have a 4.7. I put a larger 330 on just to keep it a little more ripple free, and the if you put a little larger cap on, in some cases you can get more lumens. And then up here, the cap size on the input then becomes smaller as a higher frequency. Smaller is also less current and less light, and then a larger cap would be more current and more light. And then if you do bridge across like the secondary output, if you were to bridge a cap here, you can actually get even more current, but with this low wattage thing is not necessarily what we want. I can get, I believe, up to around 2,000 or 2,100 lux out of the one bulb if I put a cap across there and then run a larger size there, albeit at several watts. So any string of LEDs, then whatever voltage you want to run. And then in terms of what we changed for efficiency on AC, again 290, we're outputting 580. That's basically 2 times the light that it was showing at 110. And then if we look at the video where I'd run the 3 of them, I was doing 1600 lumens at 4.52 watts. And if you divide out the lux, lux, it was 1600 lux. You divide out the lux here, we end up with 2.75 times, and if we divide out the wattage, we end up with 2.71. So the efficiency is the same here, even though I'm running one bulb, and I've actually even changed the bulb to be 36 volts by redoing the string of LEDs. Now practically then, we still have the advantage running to the LEDs from a super Joule ringer circuit having AC, like Lid Motor had mentioned really early on that we don't have loss, so that's going to still apply. But as far as possibly being able to make some cheaper bulbs, this might be the way to go. I know that was the intention with people asking initially, was if they could buy a big bag of cheap LEDs, and pretty much I'd say you can, and then just play around with the cap. Again, this is going to be related to frequency. You can tune your coils, and in all cases I've tested voltages from 4 volts, 5 volts, 6 volts, 8, 9, 12, 14, 16, 18, I believe 19, 24, 36, 48. I've tested a whole range of voltages, and again, these bulbs are going to be in the 220, and in all cases, whether it's a 110 bulb or a 220, the 12 to 110 volt, or 12 volt transformer seems to be the best ratio in terms of efficiency. So I would imagine in European countries, if you're running 220, you're still going to want probably a 12 to 120 type transformer for running even a 220 rated bulb. You might be able to do a 12 to 240, but I would stick on the primary in that 12 volt range. So maybe that opens up some more possibilities. That makes makes a simple circuit. And again, let me go ahead and undo this real quick so you can see what is left. You can see here 4 diodes. That's all that's on the board right now. And my .047 in series on the input, okay, to the bridge rectifier. And then because I was playing around with cap values, I had the electrolytic hooked on the circuit board, so that is still live. The electrolytic lays in right here, which is just the output filter. So that's it. 4 diodes, electrolytic on the output, cap on the input, string of LEDs at whatever voltage you want to run them at, whatever wattage. And a note too, these Utilitechs, for people that have these, if you ever have a need or an instance, the driver that is in this, the way it comes from the factory is auto adjusting. I can run these bulbs as they're set up for 36 volts. I've also run LEDs as low as 3 volts. So this will drive anything. You don't have to worry about frying LEDs because of the driver chip and the feedback. So these are handy to have around, and I would say again no less than 3 volts on the output, probably no more than 48 volts on the output, and 350 milliamps would be what these are rated at from the factory as far as the output. So diversity, ability to change things, and yeah, I hope this helps. Thanks.